of these wreak havoc with people and other organisms that evolved in systems with enough predictability that, for example, we humans were able to create a farmer's almanac and plant our crops by it reliably. And a system predictable enough that birds and butterflies and wildebeest and whales were able to develop complex and enduring seasonal migration patterns. Now those regularities are not just at risk, but are disappearing. Things are so unpredictable at the local level that despite the perfectly predictable global outcomes of global warming, by which I mean the inevitable melting of glaciers and ice caps, the inevitable rising sea levels and coastal destruction and erosion, the inevitable extinction of megafauna, the disruption of the thermal ocean conveyor belt, all that, we can with confidence say we are in the grips of intensifying local climate uncertainty. Local. The uncertainty isn't about global warming or about the ecological devastation it's bringing. It's about how human political systems on the ground will respond. That's why many scientists now refer to the phenomenon not as mere climate change, but as climate disruption. And if things are swinging so wildly that we can't predict the overall weather, can we really be said to have a climate per se? You see, in Greek and later in Latin, klima actually meant slope. It referred to the predictable zones of general weather patterns and average temperatures between different latitudes on the Earth's surface. Climatology was the study of those gradations, those slopes. People long ago charted how the average temperature taken over a year sloped gradually downwards as you moved from the equator north or south. Going north, you would encounter winter cold just as assuredly as you would encounter cold going up the slope of a mountain. People noticed similar changes in biome distribution with elevation and latitude. At the top of the mountain, you would find glaciers, and at the top of the world, you would find glaciers. Hence the notion of climate was born, all about predictable slopes. The animals and plants knew it too, hence the similarity of the biomes. So climate change literally means slope zone change. And those who argue that, well, the climate has always been changing, are only speaking in half-truths. See, there were times when the continents were distributed differently than they are today, times when today's young mountains, like the Himalayas and Sierra Nevadas and the Swiss Alps, today's tallest mountains, not yet eroded down, were nowhere to be seen. And this was only about 50 million years ago, around the time that elephants and whales first began to appear on Earth. Remember that the dinosaurs went extinct some 65 million years ago. Old eroded mountain ranges like the Barberton Greenstone Belt in South Africa date back 3.6 billion years, to a time before there was any life besides microbes on the planet at all. Now, the big mountains with the famous peaks like Everest and the Matterhorn and the big slopes leading up to them, slopes wonderful for expert skiing, began to emerge in the Eocene, which occurred between 53 and 49 million years ago, an epoch credited with starting out as the Earth's warmest temperature period for 100 million years. Wiki reminds us, however, that this super greenhouse Earth eventually became an ice house by the late Eocene. The mountains had something to do with that.